Hello, welcome to my channel. My name is Emmanuel John. I want to welcome you to today's class. If you are my returning student, welcome and thank you for showing up in yesterday's meeting on Microsoft Teams. It was wonderful. I enjoyed the time with you guys. Thank you so much. I appreciate all your efforts to helping me achieve my goal of having 250 students who would score 250 and above in JAMB this year. Thank you so much. You guys have been wonderful, and sincerely, from my observations, there is an improvement. You guys are doing much better than when we started, so I'm proud of you, and we are going to continue. So in today's video, I want to show you some questions you need to know. Yes, on waves and sound propagation. Now remember, we earlier started with dealing with past questions only. I will come up with the past questions. I will go and search for past questions, come and solve them in the video and drop it. And later I told you that I found out that that alone is not sufficient, that there is need for us to explain some key concepts, so that in case JAMB decide to navigate, try to bring out some things that are kind of minor things by the side that people may not be considered too important, you would still be able to. Remember, my goal is to equip you, to prepare you very well. So if you observe, I've been making many changes just to make sure that I have made you people well prepared, to be able to answer, to be able to approach any question, whichever way JAMB may decide to come with it. So thank you for participating. If you are coming across my video for the first time, I've already introduced my name or myself as Emmanuel John. I'm coaching JAMB student this year. I have a WhatsApp group where I give training both in the academics, that's in learning, in topics, in subjects, and also mental training, mental drills. Our mental drills have been wow. Our quizzes, my people, I've seen your responses to today's quizzes, so I'm coming to mark it. It's funny, don't worry, by the time I come to mark it, you guys, you will see. Alright, so thank you. If this is your first time of coming across my video, my name is Emmanuel John. Like I said, I'm coaching students. I am a testimony of excellence when it comes to academics. I am a graduate. I graduated in 2018 and I graduated with first class results, and I won Vice Chancellor's award of being the best graduating student in my university. So I feel also I should extend this to several other persons who would benefit, who are serious but they don't have enough study strategies and tricks to approach exams. So that's what I'm doing. So if you want to be part of us, drop interested in the comment section and I will find a way to get you added to our training platform. So thank you once again. Like I earlier said, we are looking at waves and sound propagation. Waves and sound propagation is a very important topic, yet a bit confusing. So if you are not really very critical about it, you may miss several things. So today we are going to look at it. After I have explained some things, some key concepts that you need to know, then we will go on. Yes, and I will drop some questions. Then you would try them. Remember, in our meeting yesterday, we agreed that I should explain and I should drop questions for you to submit them as assignments, and I feel that is a good approach. So if you are not part of us, unless I add you, you cannot be able to submit your assignment. So find a way of reaching out to me and I will find a way of adding you, so that after my explanation and you've seen the questions, you would be able to do the assignment and also submit. So thank you very much for having me once again. Let's continue into today's discussion. All right. Okay. When we talk about waves, what comes to your mind? Of course, you know, you have learned it in secondary school, waves all the time. All right, so how could JAMB ask a question if they want you to define wave in exams? They might say a disturbance that transfers energy from one point to another without the transfer of matter is called or is known as dash and dash. So they might now give options. I don't know if you are getting me. See, if you are smart, you can predict questions that may come up all the time. Once you are studying, you should be able to predict questions that may. So if JAMB want to find out whether you know what a wave is, if you can define a wave, they might decide to ask questions that way. Do you get what I'm trying to say? So please, the definition, know it's very important. So it's a disturbance that transfers energy from one point to another without transferring the matter. When we proceed, you will get to understand what I'm saying very well. Now, one of the practical examples of what a wave is and what we can quickly relate to is when we talk about transverse wave, example, water waves. Now, look at the picture here. You could see that picture is water. What do you observe? You observe some crests on top of the water. When you propagate a disturbance, maybe you throw a stone in water, what do you observe? Even if it is in a tank, you observe ripples moving up, and that's simply what we refer to as wave. Do you get what I'm trying to say? Now, from our definition, we say is a transfer of energy from one point to another without the transfer of matter. Now, do you know that when you propagate a disturbance on water, the ripple keep moving, but water does not change position. The matter is not moved in the process. The matter is not transferred in the process, but the energy is transferred. Do you get the point now? Because where you propagated the disturbance, there will be a movement. You observe a movement of the ripples, but then the water does not move. So what happens? Because if imagine it will look as if water is moving. No, water is not moving. So when a crest is formed, a ripple is formed, as the water goes up, it comes down on that exact position, and the energy is transferred to the next water that is at the next level. Do you get my point? So water is not transferred, water is not moved, but the energy is transferred through the water, being the medium now. So it's more like the water will just go up and come down on the same position without being transferred. The water is not swept. No, it will just go up and come down. Then it will transfer that energy to the water that is next to it. I don't know if, I'm just trying to use a layman explanation to make you get it. Because if you understand it, no matter how JAMB try to manipulate question around this thing, you will be able to answer it. So I hope you got something about wave when we talk about transfer of energy without transferring the matter. You see, this is the simple definition. If I were you, this is enough. Transfer of energy without transfer of matter. Yes, that's wave. Energy being transferred from one point to another without transferring matter. And this is how I learn. Summary. Just try to capture key points. You don't have time to read all the bulky notes waiting for you. I hope I've communicated. Alright, let's quickly look at types of waves. This is interesting. This topic, very interesting. Oh, alright. Some of you say I don't like physics. I don't see anything in physics that will make you not to like it. I don't know, sincerely. Alright, let's quickly go on. Now, under types of waves, we have two: transverse waves and longitudinal waves. Please know these two and know their difference. Very important. I'm going to explain it very clearly. Just listen to me carefully. After we are done with this, I'm going to drop questions, past questions that you should also know as you prepare for this JAMB this year 2025. Alright, when we talk about transverse, think of that word. It should give you a clue on what transverse wave is all about. So, okay, look at the notes I have there. I say transverse waves. In transverse wave, particles move perpendicular to the direction of wave. So, the particles move perpendicular. Remember, movement is not the same thing as transfer. We earlier said matter is not transferred, right? So, movement, the water moves up and comes down. Do you get that? It's not transferred. I hope this is clear. Please get this. Alright, in transverse waves, the particle, which is water now, move perpendicular to the direction of wave. Now get this, let me illustrate. When you initiate a disturbance in water, what happens? How does it happen? The water go up and down. This is how the water will be moving. Do you agree with me? Yes. Now, what will be the direction of the movement of the wave? The wave will be moving this way. Do you understand? It will be moving this way. While water is moving this way, you will see the ripple moving this way. So it's trans. It's not on the same. It's not flowing on the same direction. The particle movement is perpendicular to the movement of the wave that you have propagated. Please get this. It's very simple, and once you understand it, believe me, no question they will ask that you cannot answer. I hope you are following me. Now, the in transverse wave, remember, the particle moves perpendicular. Perpendicular means more like in opposite direction. As this one is moving this way, this one is moving this way. That's perpendicular, not parallel. I hope this is clear. That's what we talk about, transverse. Trans. So from that word trans, if you did your chemistry very well, you remember cis and trans. Let me not go to chemistry. Alright, so in transverse waves, let me explain for the last time. Please get this. If you don't get this, feel free to reach out to me either on WhatsApp, where you can even ask the question there on the group, or even here in the comment section. I will attend to you. I have a goal. I want you to score high this year. You don't need to write JAMB for the second time. You don't need to wait for admission next cycle, for God's sake. And once you prepare yourself very well, believe me, you will get the course of your desire, and you get entrance into the university of your choice. Alright, so let me explain for the last time. In transverse wave, the particle, which is the medium of transmission of the energy, we say wave is the transmission of energy or transfer of energy from one point to another. Now, I'm using water wave because it's a typical example and something we can quickly relate with. So if you propagate a disturbance, if you introduce a disturbance by throwing a stone in a water tank, what happens? From that position where you throw the stone, you begin to observe ripples. Now, energy is being transferred. The movement of the particle up and down is like this. The water will be moving like this. As it is moving up and down, observe my hand. My hand is moving. The wave will be moving. Do you get that? So the movement of the particle is perpendicular to the movement of the energy. As the water is moving up and down, it is also going like this. So the particle is moving in a vertical direction, while the wave is moving in the horizontal direction. I hope this is clear, for God's sake. If it is not, reach out to me. I'm always there for you. I want to have as many as 250 students that can have above 250 marks in JAMB this year. If you can score 320, 350, I will be very happy. And I will be glad that I'm part of those that have helped you, that have assisted you to achieve that. That's my goal. Alright, let's continue. Now, longitudinal waves is opposite. Simple. Once you know transverse wave, you will know longitudinal wave. Now in longitudinal waves, the particle move parallel to the direction of wave propagation. Simple. In longitudinal wave, the particle and the direction of the movement of wave are the same. Okay, I will still give an explanation later, but please understand that example is sound wave. If air is flowing in this direction and I'm at this point, I'm playing music, if you are in this direction, you will hear the music louder than the person that is in the opposite direction, which means air can carry sound in the same direction. That's longitudinal, which means the particle now, the medium, which is air, and the sound itself are moving in the same direction. They are in parallel direction. They are moving in the same direction. Is this clear? But in transverse, the particle is moving perpendicular to the movement of the energy. I hope this is very clear. How would JAMB ask question from this place? They may say a type of wave in which the movement of the particle and the direction of wave are parallel. Let me use that word. Are parallel. Is known as Do you get it now? Okay, they may give even options that are confusing. They may say A, transverse wave, B, light wave, C, water wave, D, longitudinal wave. Which one is the correct answer? Longitudinal wave. Very good. So once that word parallel comes, my people, remember active recall. We have been doing that, our mental drills. Alright. Alright. Thank you. Please know examples of each of these type of waves. Water waves is a dash type of wave. Is a question. Transverse, longitudinal, electromagnetic. They can bring even some wrong distance. So you should know water waves and light waves are examples of transverse waves, while sound waves, seismic waves are examples of longitudinal wave. Now I've used sound wave. Seismic wave, I don't want to talk about it much. It has to do with applied geophysics. It has to do with all this earth resonance, earth, where you send seismic wave. Maybe you want to check the probability of the occurrence of earthquake in a particular location, or you want to send waves down to the bottom of the sea, or you want to do oil exploration. You want to know whether there is oil in a particular place. So just know that it's an example. This is not even common. Hardly will you see it at your level. So I just said it so that you have at least 2 examples. Thank you. I hope you are getting me. Let's move on. I don't want this video to be long, but I want to be as clear as possible also. Thank you for understanding. All right. You must know the key difference between longitudinal and transverse wave. You have to know the difference between longitudinal and transverse wave. Okay. Now, I've already explained it. Look at the 2 arrows if you can see clearly on image 1. The blue and the yellow or gold, whichever one you are seeing. The blue and the yellow line are in the same direction. They are parallel. And what type of wave is that? Longitudinal, of course. Now look at in transverse. The blue line and the yellow line are in different direction. So while look at the wave there in red. So do you see? The blue is moving this way. That's the movement of the particle. While the energy, the wave itself, is moving this way. I hope that's clear. I don't want to take much time. Just know the key difference. Okay. Image 2 is giving more example, more clarity on that. Just look at the blue line moving in opposite direction for transverse or perpendicular, while the longitudinal, they are moving in the same direction. The direction of oscillation is the same. All right, so don't worry, I will send this material to the group in WhatsApp. For the special group, please remind me. If you are watching this, just remind me, say, Mr. Emmanuel, you said you will send the material for physics. I've sent that of biology today in the morning. If you have not checked the WhatsApp group, please go and check it now. It is there, and someone has helped us pin it there so that even if new members come in, they will be able to have access to it. Thank you. So there, I have added more here on image 3. The particles of the medium vibrate in the same direction. That's longitudinal wave. While for transverse, they vibrate in opposite direction, or perpendicular rather. Let me not use that word opposite, it's not exactly accurate. So perpendicular, yeah, because if we say opposite, it means this one is coming this way, this one is coming this way. So not opposite, perpendicular. While this one is moving this way, this one is moving this way. All right. Properties of a wave. I think I have a slide that talks about this more clear, but know the parts of a wave. We have wavelength, the crest, the trough. Okay, I think I should have a slide that talks about this, so let's go on. All right, if you have not subscribed and you are learning something, please like, subscribe. I still need to reach more students. Currently in the group, those of you that are there, you know that we are just about 120 or so, and my target is to have 250 students who will score 250, 260, 300, 350, and so on. It must be up to above 250 and above. And so I need to reach to more students. My previous videos, so many people have been reaching out to me. They are saying, oh, Mr. Emmanuel, we are learning and we want to be part of your class. Please, the first step is subscribe to the channel so that you will see many more of my videos, and reach out to me through the comment section. Like the video so that others will see it. Make comments, share it with others. Help me attract more students. This is the only thing you can help me with. The training in the WhatsApp is free. You are not paying anything, anytime. I have a goal and I want to achieve it. I have excelled academically and I want others to excel. It pains me sometimes if I see students who are serious, but they don't have this support. They don't have right strategies to approach this study. It will be appearing difficult for them. So please subscribe now. Subscribe. Don't wait later. Subscribe and hit the subscription button now, and hit the bell button for notification, so that once I post a new video, you'll be among those that will first know. Like it also. Doing these things will help the video go more viral and help me attract more serious students only. Not everybody will, please, to attract serious students. Thank you so much, and we go on. All right, good. Yeah, this was the slide this is the slide I was talking about on the parts of wave. Please expect questions from this place in JAMB this year. Either they will ask you trough, crest, amplitude, wavelength, frequency, period, and so on. So get yourself prepared. Now, look at this image very well. Tell me now, what type of wave is this? We have two types of waves. Is it longitudinal or transverse? Just look at the picture. Look at the movement of the particle and the movement of the wave. What's your answer? All right. Yeah. If your answer is transverse, you are wrong. Is not wrong. Transverse is the correct answer. All right. So transverse is the correct answer. You see that the movement of the particle is perpendicular to the movement of the wave. The wave is moving in this direction. Observe. Do we get that? All right. I have short definitions here. For crests, crest is the highest point of wave where the displacement is maximum. Now look at on the image. Look at the part labeled crest and never forget it, please. So is the highest point. They might ask the question, the highest point of the wave where the displacement is maximum is referred to as the highest point, that's crest. Remember, apex, top, zenith, crest, they are all talking about the same thing. They are synonyms, something at the top. So don't forget that. If you can remember that English word. Alright, the next one is trough. Now if you have done agriculture, remember, or animal husbandry, trough. Do you remember water trough? In poultry, trough, where they used to give poultry birds water. So, and trough is deep, so that the water will be able to settle. If trough doesn't have an inside, how will you put water for it to stay? So if you can remember, trough is inside, while crest, the top, the highest, trough, crest. Use these tactics. That's how I used to remember things. You guys. Alright, so we have amplitude. Amplitude is the maximum displacement of the wave from its equilibrium. Now look at amplitude there. Look at the picture again. You would see amplitude there. Look at the red line. So the maximum displacement of a wave from its equilibrium is referred to as amplitude. Now the black line, the horizontal black line, is referred to as the equilibrium. That should have been the normal position of water at rest if it is not disturbed. That should have been the normal position, and we refer to it as equilibrium. Alright, let's quickly go. We have wavelength. Wavelength is a distance between two successive or consecutive crests or trough. Look at the black line there at the top where wavelength is written. So between one crest and another crest is referred to as wavelength, or between one trough and another trough. The distance is always the same. The distance between one crest and one crest is the same thing with the distance between one trough and another, but they must be successive, consecutive. Not that one trough here we skip one trough and no, not that one. Alright, frequency has to do with the number of oscillations or cycles per second. How many cycles does the wave go in 1 second? That's frequency. Then period, the time taken for one complete oscillation. Now observe that frequency and period are somehow similar but not the same. Whereas in frequency is the number of oscillation per second. Do you see it? It's measured in per second, but period is time taken for one complete oscillation. That is a crest and a trough. That's one oscillation. Alright, thank you. Let's move on. Okay, we have a formula that is very, very important because there will be calculations and questions I'm going to give you. Don't think there's no calculations. Oh, thank you. I'm happy you guys are beginning to like calculations these days. The last physics assignment I gave on calculations, it was wow. You guys have really, you have made me proud. Almost everybody was just getting complete. All. I was like, I thought people don't like calculations. So I'm happy you guys are making me proud. I'm talking to students who we have already been working together. If you are not part of them, you can be part of us. I've already said how you can be part of us. Drop a comment on the comment section indicating your interest. Just say I'm interested in your class, Mr. Emmanuel. I will find a way to add you. Alright, so if you want to calculate the speed of a wave, you use the formula V is equals to F lambda. That sign, I hope you can see my formula. That sign lambda is referred to as lambda. That's the wavelength. So you can calculate the speed of a wave, and the formula is velocity or speed is equal to frequency times lambda. That's wavelength. So if I say a wavelength of a wave is 5 meters. Remember, wavelength is calculated in meter because it's distance, the distance between one crest and another. Alright, so if I say the wavelength of a wave is 2 meters and the frequency is 10 hertz. What is the wavelength? What is the speed of the wave? Simple. The speed is 10 times 2. That is the frequency times the wavelength, which is 20 meters per second. Don't forget the unit. Oh, please know the unit of all this. Thank you very much. Let's quickly move on. All right. Waves has properties. Waves has properties, and these properties sometimes seems to be confusing if you didn't get them very well. So let me explain them clearly and in simple terminology so that you get it once and for all. All right, we have reflection. We all know reflection. This is a simple English term. It's not any other normal reflection. If you put a mirror and you light a torchlight directly to the mirror, what happens? The light will reach the mirror and it will reflect back. So the waves bounce back. The bouncing back of waves off a surface is what we call reflection. All right, then we have refraction. Refraction. When waves pass from one medium to another, they change direction. Now, a typical example is if you get a stick and put it into a bowl that has water in it, it will appear as if the stick bends. Have you ever observed that? You can actually try it. I like practicals. See, when I was in secondary school, I did many practicals. They will tell us this is. I will go and try it. Yes. I used to have a friend then, Andrew. Hey, that guy and me, we used to do practicals, so we will go and try it. Yes. All right. So you can try it. When you dip a stick inside a water, it will appear as if, and you look at it will appear as if the stick bends, but it didn't actually bend, because the stick, when you remove it out of water, it will look straight again. So what's actually happening? So refraction is taking place when light pass, or when a wave pass from one medium to another. Density actually plays role here, but maybe later I will do a better explanation for you to understand. So when a wave passes from one medium to another, from a dense medium to a denser medium, a refraction occurs, and that's a change in direction of the wave. I have an image there. I will explain more. Then we have interference. Two waves can combine to form one new wave. That's interference. They interfere, they come together to form one wave, more like fusion. Yes, so they join together to result to a single wave pattern. That's interference. All right, the last one is diffraction. When waves pass through an opening or around an obstacle, sometimes it spreads. Do you see? Now look at diffraction and interference. Looks somehow opposite. These are some of the tricks you can use to remember things. See. Okay, let's see now. Let me show you something. This is reflection, refraction, interference, and diffraction. Now I compare the two. Okay, I already know reflection, even if they wake me up from sleep. Let's assume that I don't know refraction, interference, and diffraction very well. I will just create an acronym. I will say refraction, that's bending. So I can say RB. Interference, combining, I will say IC. That RB for refraction means diffraction, bending, interference, combination, diffraction, D what? DS, correct. Alright, so diffraction, spreading. Do you see? Hey, see, if you guys are not doing well in your academics, so I don't know, use your brain, make things easier for yourself. So if I were you, these are some of the things I will just write out. Even as I'm giving this note now, you can have your notebook and be writing some things. Even when you come to revise, it will be easier for you. And when you are doing active recall, it will become easier. For example, I've written R for refraction, bending, that's RB. and I've written IC, that's interference combination, and I've written DS, that's diffraction spreading, and at the top I wrote as a topic properties of waves. Do you know that anytime I come to revise it, I don't have this PowerPoint, I don't have anything on me, I will just open, I will say RB, R, okay, R, what does the R stand for? Okay, R is for refraction. Okay, B, what does B? Okay, B. Yeah, bending. Do you see it? You are training your brain, you don't know. You are training your brain, and when your brain, once your brain can stick to this kind of patterns, forget it. I'm telling you, not what they will teach you again, except that thing is not, you cannot see it, you cannot learn it, that's just it. But there will be nothing that will be too hard for you again to understand. Some of you, this call is too difficult, you won't say it's too difficult. There is nothing too difficult. Some people have learned it, they have mastered it, and they are doing well in it, and you are now saying it's too difficult. What makes you different from them? So the only difference is that they have known some of these tricks, some of these strategies. So why not know them and apply them too? Thank you very much. I hope you understood my explanation. Let's quickly look at the image. I said I don't want this video to be too long. Alright, so we take an example of light. Now look at reflection. The first figure, reflection. Do you see? See the two arrows. The light hits the mirror and reflects. Look at refraction, which is bending. The light hits the medium and change direction. Look at interference. Observe carefully. There is plus there. I don't know if you can see it. White. There is one wave at the top plus another wave at the bottom, resulting to one single wave particle or pattern. Do you observe that? That is what interference. I've earlier explained, two waves combining into one. Then look at diffraction. Observe that it was one wave in the first place. After it has passed through a space, through an opening, is as small, the waves increase to 2. I hope this, please let's move on. If this is not clear, just drop a comment on the comment section. I will attend to you. Alright. Propagation of sound wave. Okay. Sound waves is very important too, and you may be asked, I don't know if this formula is that too important, but please know it. I just felt I should add it. There are some things that are important, but alright, so I won't waste much time here. There is a formula for calculating the speed of sound through a medium. There is a formula, and the formula is V is equal to the square root of B over P. B is defined as Bulk's modulus. You'll be given it if they ask you any question under this. While P is the density of the medium. This would also be given if you will be asked to calculate the speed of a sound wave. Then we have frequency and wavelength. Like other waves, sound wave has frequency and wavelength. Please note that. Sound in different mediums. Sound travels at different speeds in solid, liquid, and gases due to differences in density and elasticity. I'll explain this more later. Okay, propagation of sound waves. Acoustics. Please know what this is. Yeah, and you should expect a question around there. What is acoustic? The study of sound waves, including their production, transmission, and effects. So there are 3 key words to define acoustics. Study. Okay, let me not even include study. You can start defining anything, almost anything as a study, but not everything. Okay? Sound waves, that's their production, transmission, and effects. What is acoustics? The study of sound waves, their production, second one, transmission, third one, effects. So if I can remember these 3 keywords, production, transmission, and effect. And look, they are logically arranged. What does that mean? What does that mean? Production. You first produce. After you produce, you transmit. Effect means result. So if I produce sound wave by banging something, bam, what happens? The sound will be transmitted and the effect will be produced. So it's simple. Do you get it? Then we have Doppler's effects. Okay, let me not answer the questions I'm going to ask you all. I know some of you are listening attentively so that they'll get everything to score all the questions I have for you. Alright, so Doppler's effect is the change in frequency or wavelength in relation to an observer moving relative to the source of the wave. So this Doppler's effect actually has to do with frequency. It has to do with change in frequency. We have one radio something now in the hospitals that apply this Doppler's effect. I think that should be under what do we call it? All this scanning. So they adopt that. It's actually a mechanism. Some of these things are just principles that are applied to build medical equipment that used to work. So it has to do with this frequency. Let me remember now. Ultrasound. Yes, ultrasound. Do you know what they do in ultrasound? If a woman is pregnant and they take her to hospital, they say, hey, we want to test the position of a baby, we want to do this, we want to do that. Do you know that sometimes they send waves into the stomach? Do you get what I'm trying to say? So some of these things are even used to apply for use in medicine. So if you want to calculate Doppler's effect, the formula is F prime. F prime is the observer's frequency. If you want to calculate observer's frequency or observed frequency, is equal to the source of frequency. That's F. We have V, which is the speed of the sound in the medium, and we have V naught. The V with small zero, that small zero is referred to as naught. V naught is equal to speed of the observer, and Vs is the speed of the source. So I wouldn't say you should not know this formula, but it's a bit advanced, and not advanced. Please, JAMB may decide to ask it because it's part of syllabus. All right. Okay, let's go. All right, we have characteristics of sound waves. We have pitch. Pitch is the perceived frequency of sound, and high frequency correspond with high pitch, and low frequency correspond with low pitch. I know many of you might have known this already. So pitch has to do with frequency. Let me repeat it again. Yes. One of the following is associated with pitch. A, frequency. B, amplitude. C, loudness. D, quality. What's the correct answer? Frequency, of course. Don't ever forget this, please. Pitch and frequency, they go together. If the frequency is high, the pitch will also be high. If the frequency is low, the pitch will also be low. So pitch is a perceived frequency of a sound, and frequency has to do with the number of occurrence, how it occurs. Alright, loudness is the perceived intensity. If I'm playing music now, you say, this music is too loud. So the intensity, intense, how hard, how heavy, how strong you hear it, is what we call loudness, and is related to the amplitude of the sound. Pitch is related to what? Frequency. Loudness is related to what? Amplitude. Never forget to. Alright, quality of a sound. When we say this sound is quality, it's a quality sound. What do we mean? Quality is a characteristic of sound that allows the listener to distinguish between different sources of the same pitch and loudness due to harmonics. So is a characteristics of sound. That's quality of a sound is a characteristic of sound that allows the listener to distinguish between different sources of the same pitch. If a pitch is coming from different sources, that characteristics that allowed you to distinguish between different sources of the sound is what we call quality of a sound. Okay, all right, so let's examine these pictures very quickly. Okay, we have air molecules there. Okay, there is something I intend to explain using this picture. Is in another slide. I will explain that better. Now look at the sound, the one below. Do you observe the two different sounds? Now the first one, which is A, is a musical note because it has a quality sound. The listener may be able to distinguish between the source of the notes or music. For example, keyboard. If you play keyboard, you will be able to differentiate or distinguish between the different sounds. But when we talk about noise, it's irregular, haphazard, mixed up, that there is no meaning out of it. You cannot be able to distinguish. That's noise. I hope you get this. Let's go. There is something I want to explain. Alright, propagation. Now, sound waves travel at different speeds in different substances. In solid substance, sounds travel fastest due to the close arrangement of the particles. I will explain this better. But one thing I want you to know is that sound travels in solid particles or solid substances faster than any other substance. If you see in your exam question, sound travels fast in which of the following, and you see solid and you skip it, hey, let me not see it though, because I'll come and kill first. Alright, that's just a joke. I will not knock you, but please don't make that mistake. Don't make that mistake, please. Alright, so liquid. Sound travels in liquid slower than in solids because the particles of liquid are not closely like that of solid. Then gases. Sound travels slowest in gases due to the separation of particles. Note these three substances, and they may decide to say in solid, liquids, and gases, sound travels. Okay, arrange the following from, arrange the following based on the speed of sound through them, from the slowest to the fastest, and they now say solid, liquid, and gases. Will you be able to arrange them from slowest to the fastest? So from slowest to start from gas, liquid, and solid. From fastest should be liquid, solid, liquids, and gases. I hope this is very clear. Alright, what's the reason? Observe these pictures here. See how the molecules of solid is, how the molecules of liquid is, how the molecules of gas is. Remember, we say wave is a transfer of energy through a medium without actually transferring the medium itself. So if the particles are closely jam-packed together, they will be able to pass the wave. They will be able to pass the energy faster than if there is space between the particles. So if there is space, that vacuum, that space becomes difficult for the energy to be passed through. And let me say this. I have explained this in one of the videos I've published. I don't know, I can't remember which one precisely, but I've said sound does not even travel in a vacuum. This room where I am now, if everywhere can be sealed and all the air inside should be removed entirely, all the air should be removed, and I'm inside here, and the heat, which type of metal is more sonorous, makes more sound than any other? Okay, let's say silver. If they hit silver, bam, provided that there is no air, that this place is a vacuum, I cannot hear anything. Peradventure, you now see the list of these substances: solid, liquid, gases, vacuum. Which of the following does sound travels slowest? Which one will you pick? Gas? No. Vacuum. Thank you. So in vacuum, it's as though sound does not even travel. Even if it travels, it's very slow. Please get that. And the reason is because there are no particles. There is no air. Air is the medium for sound mostly. So there is no air. You have removed all the air. The place is a vacuum. So sound does not travel. I hope this is clear. Please, I don't want this thing to be long. Now, I just put a table of some of the materials and the speed of sound in them. Now, the speed of sound in air is a constant. Don't forget this. Sometimes they may give it to you in question, sometimes they may not give you. Now, at room temperature, what is room temperature? 25 degrees Celsius, correct? Don't forget this one. There are some constants, you should know them offhand. Yes, room temperature, atmospheric pressure, what else? There are many, so know them. Now look at this table. I am just concerned about that of air because you may be asked calculation question. So at room temperature, sound travels in air at the speed of 343, let me say 44. This is 20 degrees Celsius. Actually, the ones I've been seeing is 44. But I know the difference. The difference is the temperature. Now observed, I have two air here. I don't know if you can see this. Can I zoom it? Yes. Observe that I have two air there. The first air is at 40 degrees Celsius. And what's the speed of sound in that kind of air? 355 meters per second, which is far bigger than the air at 20. So the lower the temperature of the air, the lower the speed of sound through it. So, but at room temperatures, sound travels at 344 meters per second. So, in case you are not given during exams, use 344 meters per second. But most times, they will give you the value. Is that okay? Just know it. Thank you. Alright, we go on. Okay, we are here now. So what questions do you expect in JAMB 2025 under waves and sound propagation? What question do you expect? From what I've shared now, I've shared many questions, so do you observe that? Okay, so which one do you expect? Alright, so this will be your assignment now. I don't know how to do it. Okay, now this is what will happen. I will show the assignment questions. I will read them for you. I'm not going to answer them. So get your book ready now. Get your book so that as I'm reading them, just write the correct answer. You don't need to write question. Just write question 1A, question 2B, question 3C. For calculation questions, copy the parameters so that later you can go and work them out on your own and finish up. Then you now put the correct options, and you put everything together and send it to my WhatsApp. Oh, did I say you had to send it to my email today? Okay, let's not make it today. You see, this is one of the things I'm doing that no other person is doing. The way I'm taking you this tutorial, you should know that I have a goal that I want to achieve. I'm not just doing it for doing sake. I try to provide a well-rounded training for you. Look at the meeting we had yesterday on Microsoft Teams. Many of you did not have any meeting on these online platforms, and I told you my first interview was on Google Teams. Thank God I knew how to use it. I would have missed it. Do you see it? Some of your lectures, by the time you get to the university, they will be online. I hope you know that. Your lecturers will ask you to submit assignment through email. So I want you to master this thing so that even by the time you enter university, you'll be smart. So as we are preparing for JAMB, we are also learning things that will be of help to us in the future. Alright, back to our business. For our calculations questions, please pick the parameters, or no problem, you can play the video again. Just fast forward it to that position, and you can even pause the video so that you can copy what you need to answer the question. So I won't stay long here because that's the end. Alright, so the first questions we have here. Question 1 says, so if you are with your book now, you can just write the correct answer. Just write question 1 and you write the correct answer for. So then later you now put everything together and send it to my WhatsApp. If you are not part of us and you want to do this assignment or you want to be part of us, drop a comment indicating interest. Or better still, I'm going to drop the WhatsApp link at the description, but in case you did not see it, just drop a comment. I think that will be faster. Just drop a comment on the comment section. Just say, I'm interested in joining your coaching class, Mr. Emmanuel. I will see it and get how you can get you part of us. Alright, question 1 says, which statement best describes a transverse wave? Which statement best describes a transverse wave? A. Particles in the medium move parallel to the direction of energy transfer. B. Particles in the medium move perpendicular to the direction of energy transfer. C. Energy transfer in the wave is dependent on the medium compression. D. The wave travels faster in gases than solids. Choose your answer. Alright, we go to question 2. Question 2 says, which of the following phenomenon describes the bending see, which of the following phenomenon describes the bending of a wave as it passes from one medium to another with a different speed? A. Reflection. B. Diffraction. C. Refraction. D. Interference. Choose the correct answer. Okay, can we go to the next question? Yes. Alright, question 3. The Doppler effect is most accurately described as A. Increase in wavelength amplitude when a source moves away from the observer. B. The change in observed frequency when there is relative motion between the source and the observer. C. The phenomenon of wave bending around the obstacle. D. The complete reflection of sound waves off a rigid surface. So pick your correct answer and write it down. I'm going to send this material in the special group, but that will be after assignment, so most likely tomorrow. Don't forget, you have to submit the assignment to my WhatsApp DM. Don't drop it in the group. Alright, so these are the first 3 questions. We have more. I have 10 questions for you. Question 4 says, which property of sound wave primarily affects its pitch? Which property of a sound wave primarily affects its pitch? A. Amplitude. B. Wavelength. C. Frequency. D. Speed. If you don't get this one, go back and watch. All these answers I've stated them. Alright, 5. Sound travels slowest in which of the following media? A. Solids. B. Liquid. C. Gases. D. Vacuum. Question 6. I hope you have picked your answers. Good. Question 6. The quality of a musical note is determined by A. Speed of the sound in the medium. B. The amplitude of the wave alone. C. The combination of overtones and harmonics. D. The wave's period and wavelength exclusively. Pick your answer. Is that taken? Yes. Alright, we have 4 more questions. Okay, I have calculation question for you. See, these guys, I've even given you the formula here. Oh my god. I shouldn't have given you the formula. Alright, notwithstanding, let me see. No problem. Question 7. Quickly write out the parameters. A wave on a string has a frequency of 10 Hz. Frequency 10 Hz, F equal to 10, and wavelength of 2 meters. Wavelength 2 meters. That's lambda. Lambda is the wavelength. Lambda is 2 meters. What is the speed of the wave? A, 5 meters per second, B, 8 meters per second, C, 10 meters per second, D, 20 meters per second. So the formula you have to use is V is equal to F lambda. Alright, the next question. Question 8. A sound wave traveling in air has a frequency of 500 Hz. If the speed of the sound in the air is 343 meters per second, what is the wavelength? What is the wavelength? Remember, lambda is the wavelength. Lambda is the wavelength. And to calculate lambda, you use lambda is equal to V over F. That's speed over frequency. So, speed over frequency. Just observe, we are just using the first formula, the formula in question 7, making lambda the subject of formula. Don't forget, you have to know these manipulations in physics, making the subject of formula. So, look at the equation in the formula in question 7. You just divide both sides by F to make lambda the subject of formula. That was what was done. So, I hope you pick the parameters for question 8. Frequency 500 Hz, speed 343 meters per second. So the options: A, 0.69 meter, B, 0.86 meter, C, 1.72 meters, D, 2.15 meters. I hope that's second. Then last page. Alright. So question 9 says a train is approaching a stationary observer at the speed of 300 meters per second. The train whistles has a true frequency of 400 Hz, assuming the speed of the sound is 343. Do you see now? 343. Speed of sound in air is constant. So this is at room temperature at 20 degrees Celsius. They are given at 20 degrees Celsius. Remember, room temperature is 25 degrees Celsius. Atmospheric pressure 1 atm. Let me not go into these constants, please. What's the observed frequency? That's F prime. I've given this formula already. It's even here again too. Alright. So you use Doppler's effect formula. F prime is equal to F open bracket V all over V minus S. So this is also a rearranged formula. So please, Vs is 30 meters per second. I've already given everything. So choose the correct options. A, we have 370 Hz. B, 412, C, 436, D, 440. Last question. A wave traveling at 12 meters per second has a wavelength of 3 meters. What is the frequency? What's the frequency? Do you observe something? We are still using the formula we used in question 7, only that we will make F the subject of formula this time around. If you are not part of my student and wish to do this assignment, do it and reach out to me on comment section so that I will add you to our group. Thank you everyone for staying together with me. This class is a bit long. I always like short classes, but I cannot afford to just do jaga work and go. No, don't be in hurry. See, it requires a price. If you have watched to this point, please write in the comment section, I have watched to the end. Let me know persons that have even managed to reach this place. Let me, sincerely, you deserve a salute. If you are not able to devote time to learn, don't think you will go far. I know some people have already quit at the first minute. Do you get it? So, but if you have reached this point, I salute you. You are those kind of persons that can insist, and you have the potential to be successful in life, not just in academics. If you cannot persist, insist, if you don't have resilience to stay, if you don't have the stamina to remain, forget it. So don't be these sharp people. Thank you if you have reached to this point. Okay, have you subscribed? Did you like? Is there anyone you want to share it with? Share with them, feel free. Reach out to me in the comment section if you are not part of us. If you are part of us, like, share, make your comment. Let the video go more wider so that many other people will see it, so that I can achieve my goal. You can help me achieve this goal. I need to attract more students, serious students. Thank you very much, everyone. Thank you for staying to this point. Good afternoon and God bless you. Thank you.